Google Cloud Platform Services. In this nugget, we're going to take a look at where Google Cloud Platform fits in the cloud computing service spectrum, and then we'll take a brief overview of all the major products and services here in Google Cloud Platform. Let's jump in. The three major service categories we have in cloud computing today are infrastructure as a service. This is essentially us renting out compute resources from a cloud provider, right? The cloud provider is responsible for the actual infrastructure, responsible for the bare metal and doing maintenance and upgrades and that sort of thing. And we just simply spin up virtual machines and have full control over whatever we put on them. And this is Compute Engine in Google's cloud. We also have platform as a service, and this is where a cloud provider will take care of not only the hardware layer, but also the software layer, the environment, the runtimes, the dependencies, everything your application needs to run, fully managed by the cloud provider. And in Google's case, this is App Engine. And this is great because all the things that are hard to do with an application, such as scaling and redundancy and all that stuff, fully managed by Google. So what that means is, as a developer, you just need to focus on your application, focus on your code. You code and you go. Code, deploy, and on to the next version. It's a very attractive option for many use cases out there, such as startups or small teams or companies that may not have the manpower or the budgets to manage and support their own infrastructures. Finally, we have software as a service. And this is where a cloud provider will expose software over a network or over the internet. So you don't have to worry about installing anything locally, and we're not responsible for anything infrastructure-wise or beyond. And this is, of course, things like Gmail and Google Docs. And this is not what the Google Cloud Platform is. Google Cloud Platform is infrastructure as a service and platform as a service, and there's a whole bunch of other things in between. So remember, infrastructure as a service is managed infrastructure. We are responsible for the software, the operating system, everything that goes on these machines, which is going to result in a little bit more when it comes to management. Platform as a service is managed services. It's going to be less management overhead because we're not responsible for either the hardware or the software on those machines. As we zoom in a little further, we can see Container Engine, and we can see that this is more towards the infrastructure as a service side of the spectrum. It's all about clusters and treating a data center or a pool of machines as one giant resource. And it's also all about declarative management. So we can declare how we want things configured in a file rather than going onto the machine and doing it ourselves. Machines know how to do things, right? So why not tell them how to do it rather than do it for them? We also have things like managed VMs, which is in the middle, but still more towards the platform as a service side of the spectrum. This is what allows us to have a little bit more control over the runtimes. So if you're an App Engine user and you wanted some of those Compute Engine features, that's kind of managed VMs, the best of both worlds. And on the extreme end of the platform as a service spectrum, we have cloud endpoints, which is essentially a way of building our own web service in the cloud and exposing functionality or data through an endpoint. Google's cloud has a lot to offer, and it's growing at an incredible pace. So what I want to do for the rest of this nugget is just take you through all the major services that it offers. And we'll start here with the compute category and look at Compute Engine, Container Engine, and App Engine. Google Compute Engine is what we'll be using to build our own infrastructure in the cloud, our own cloud-based networks. And it starts by building a virtual machine. And it's a lot like building a real PC. If anybody's ever built a real PC before, what do? You define your physical specifications. You know, what do you want for CPU and memory? What do you want for disk? What kind of operating system do you want on that machine? Same kind of deal up in Compute Engine, except you don't have to physically do it all. You're just doing it through either a command line or a browser, specifying what you want for memory, CPU, disk, operating system. You click a button, and under a minute, you have yourself a computer in the sky that you can either SSH or RDP into. It's really, really neat. And then once you get a couple of them going, you can create a network and tie them all together. So I like to tell people playing in Compute Engine is like playing data center Legos, right? Because you have all these resources that you can spin up individually, and then you tie them all together, and boom, you have yourself a machine ready to go in the cloud. On to Container Engine. So Google has been doing containers for a very long time. Almost everything at Google runs in a container. They've even built their own internal systems to help them manage, schedule, and coordinate containers. And so what they did is they took all that knowledge of working with containers over the years, and they reimagined it in an open source project called Kubernetes. So Container Engine is Kubernetes plus Docker. Docker, the currently supported container format, there will be more in the future. Docker for hosting containers, Kubernetes for controlling, orchestrating, scheduling containers, and ourselves configuring the whole process declaratively through configuration files. It's a win-win-win. It's a pleasure to work with, and you'll see what I mean. The first time you get in and you get your hands in this stuff, you'll be like, wow, this is really cool. And we'll be doing just that a little later on in the course. Rounding out the compute category is Google App Engine, and this is a developer's dream because we don't have to worry about the environment that our application runs on. We can focus on features and focus on our application rather than focusing on infrastructure. Currently supported languages are Java, Python, PHP, and Go, and the process goes like this. We configure our local machine with the SDK, which mimics the Google App Engine environment on our local machine. So we do all of this stuff locally. Our development, testing, and eventually deploy it up to the cloud, and Google takes care of all the hard stuff. And I'm talking about things like auto-scaling. What happens with a traditional web application when you suddenly get a spike of traffic? Right? Performance is going to degrade and you're running around trying to find out how you're going to add more capacity into your infrastructure. We don't have to worry about that here. And we have lots of bells and whistles and controls that we can put into place to tailor it to our needs. Let's move on to our storage options here in Google Cloud Platform and talk about services such as Cloud Bigtable, Cloud Storage, Cloud SQL, and Cloud Data Store. Google Cloud Bigtable is a fully managed, high-performance, extremely scalable NoSQL database service that is really meant for those internet-scale workloads where your data set starts in the terabyte range and can scale up to the petabyte range. It's accessible through the industry-standard open-source Apache HBase API. HBase is the database behind Hadoop, and this gives us native compatibility with our existing big data infrastructures. And if you've ever set up a big data infrastructure, you know that setting it up and keeping it up requires a lot of time and a lot of manpower. So this is great because now we can send the burden of managing a big data infrastructure off to Google, and we can focus on what's important, and that is the data. Plus, Cloud Bigtable sits on top of the real Bigtable, the one Google built many years ago that's running today in their data centers that powers some of their biggest products, Gmail, YouTube, web search. And that's also, by the way, where HBase came from. HBase is the open source implementation of Bigtable, and we know that nothing is ever as good as the real deal. In fact, Google boasts about a 2 times performance per dollar gain over any other unmanaged NoSQL implementation. Next up, we have Google Cloud Storage, which is our highly durable and highly available object storage service. This is where a lot of people get started out in the cloud because it's a no-brainer for storing things like backups and archiving data. And what's nice about Google Cloud Storage is we have a lot of different storage classes, so we can really streamline storage based on our accessibility and availability requirements. For example, we have standard, nearline, and DRA buckets. A bucket is the container that we store our objects in. And all of those storage classes have different availability and latency properties associated with them. So this allows us to optimize our cost based on the kind of data we're storing in cloud storage. It's also worth noting that all of these storage options can be accessed through a nice, consistent RESTful API. And we have client libraries, which makes it even easier. And more on that when we get into interacting with GCP. Next up, we have Google Cloud SQL. Our storage options wouldn't be complete without some kind of a relational database up there in the cloud, and that's what Cloud SQL is all about. Fully managed MySQL databases. And once again, we don't have to worry about anything outside of the database, right? We hand all of those administrative burdens off to Google, things like patches and updates and backups and replication, so we can just focus on everything inside of the database. And it uses standard MySQL, so it'll work with the MySQL tools you already know and love, and we can hit it from anywhere, from our GAE apps, from our GCE instances, and even from external applications running on-prem. Our final storage option here is Cloud Data Store. And this is another fully managed, highly scalable, high-performance NoSQL database. But unlike Bigtable, this one is perfect for storing highly structured application data because it maps very well to object-oriented and scripting programming languages. It's also schemaless, which makes it very, very easy to work with, right? It's a document-style NoSQL database, so developers can just put their objects in there. They don't have to worry about mapping them to this really rigid schema. Makes it very, very developer-friendly. It also comes with a lot of really great features built right in. Local development tools, automatic scaling up to literally billions of objects, support for transactions, and as with most things in Google's cloud, it has a RESTful API, so we can hit it from virtually anywhere. One thing I love doing is talking to a developer after they've used the data store, because that conversation almost always goes the same way. Shouldn't I be doing more? That was way too easy. And the reason being is because application storage has been dominated by the relational world. So all the developers out there have relational knowledge just ingrained in them. And so when NoSQL came along, it kind of turned all that on its head. And the data store is literally that easy to work with that you just feel like there should be more to it when really there's not. I liken it to the first time you get into a self-driving car. You know, you're going to get into that car and you're going to sit there and you're going to be like, shouldn't I be doing something? No, let the car do all the work. You just sit there and enjoy the view. So those are our storage options. And one question I get quite a bit these days is what's the difference between Bigtable and Cloud Data Store? You know, they're both NoSQL style databases. When would I use one over the other? Because we all pretty much have a good understanding of what cloud storage is all about, right? Blob data, images, videos, backups, archives, binary type stuff. And Cloud SQL for relational databases, what we've been working with for a very long time. And what I like to do is send them over to the documentation, because I think Google recognized, these are just different ways of thinking and different ways of doing things, and there's just NoSQL stuff is still kind of new. And so at the bottom of both the Google Cloud Data Store docs and the Cloud Bigtable docs, we have this what it's good for section and comparing it with other storage options. I just love these right here. So what Bigtable is good for? Marketing data, financial data, IoT data, time series data, and here's a really important statement. It is not good for small amounts of data, less than 1 terabyte. It's not a relational database. It doesn't support SQL queries or joins, nor does it support multi-row transactions. And here it is. So if you need OLTP, Cloud SQL. OLAP, BigQuery. Immutable blobs, Cloud Storage, and highly structured objects, or if you require support for transactions and SQLite queries, Cloud Data Store. And then again, over on the Data Store page, same thing. What Data Store is good for and comparing it to all of the other storage options. Moving on, we know that Google has mastered the realm of big data. So it only makes sense that they have some pretty cool big data services in GCP. Let's take a quick look at each one. One of the first big data tools Google added to GCP was BigQuery. And this is an incredible tool because now we don't have to support our own data warehouse infrastructure. It's essentially our analytics database up in the cloud. And what's special about BigQuery is a couple of things. Number one, we can do near real-time interactive analysis of incredibly large data sets. And we're talking we can query terabytes of data in seconds. Another really special aspect here is we can leverage our existing skills, our existing SQL skills, to query this data. And even ingesting data into BigQuery is a breeze. We can load it from Google Cloud Storage, we can load it from Google Cloud Data Store, and we can even stream it in through APIs. Plus, there's a lot of other tools out there that integrate very well with BigQuery to do things like ETL and visualization. So a fantastic service that is also a pleasure to work with. Next up, we have Google Cloud PubSub. This is our scalable and reliable enterprise messaging middleware. Because oftentimes when you have a distributed system, you're going to have components all over the place. You could have some on-prem, you could have some in the cloud, you could have some across clouds. So no matter where your applications live, PubSub gives us a nice component that sits in the middle of everything so we can pass messages between these applications, again, no matter where they live. It supports one-to-one, one-to-many, many-to-many messaging, as well as push and pull delivery models. Another great big data service we have here is Google Cloud Dataflow. So this is how we can construct our own data processing pipelines. And a lot of people think ETL, right? You take data from a source, do some transformations, send it to a destination. And while that on its own is very cool, and yes, the Dataflow is perfect for that, it can also do a lot more than that. We can do analytics while we're streaming that data through Dataflow in real time. We can also do batch and stream processing, and we have one single unified programming model to do it all. Plus, it's extremely fast, versatile, and can handle large data sets with ease. In fact, Urs Hosel, VP of Infrastructure at Google, said that Dataflow has effectively replaced MapReduce internally at Google. MapReduce really starts to slow down once your data sets get in the petabyte range. So another great tool for moving data around. Next up, we have Google Cloud Data Lab. What good is all that big data if we can't gain insights from it? And that's what Data Lab allows us to do. Of course, we could do that before, but we needed third-party tools to do so. Now we have a nice solution built right into the cloud. This is a really powerful interactive tool for exploring, transforming, analyzing, and visualizing data that lives in BigQuery, Compute Engine, and Cloud Storage. And it's actually built on top of Jupyter, which is a nice open source tool that lets us combine SQL, Python, content, charts, all that stuff in a nice, simple web UI. Rounding out our big data tools in GCP is Google Cloud Data Proc, another great tool that's going to save people a lot of time and money. Because again, setting up big data infrastructures is expensive and it's timely, and there's a lot of wasted resources there when it's not doing anything. And Dataproc takes care of all that for us. It's a fast, easy, managed way to run Hadoop and Spark and Hive and Pig and a lot of the big data ecosystem on GCP. We can spin up clusters fully loaded with all this stuff, run our jobs, and spin them down and only pay for what we use. So by doing this, Google just made the big data scene far more attractive and accessible for everybody, right? Because number one, again, we don't need our own infrastructure. But number two, if we already have our own infrastructure, it makes it very easy to take those jobs and port them up here to Dataproc so we can get rid of that existing infrastructure. It's great that we're built minute by minute. We can, again, spin them up, run our stuff, tear them down. On top of that, we get anytime scaling, which is huge because now we can scale up or scale down as our jobs are running. So there's a brief look at all of the current big data options in Google Cloud Platform. We'll be covering BigQuery in this course, and we'll be covering all of these in a big data track coming out in the near future. Now let's take a look at app services, and this is really going to entail APIs and endpoints. There's a lot of APIs, and they're all very easy to work with in Google's Cloud, and we can use them to enhance our applications. Google Cloud Endpoints allow us to build and expose our own RESTful APIs hosted on App Engine, which is great because that means our APIs get a lot of those sweet features that App Engine apps get. Right? And I'm talking about scaling, DOS protection, high availability, OAuth 2 supports. We don't have to build our own security layer. We can piggyback on top of Google accounts. Plus, we can even generate our own client libraries, which will make it easy for anybody to interface with these APIs. Google exposes virtually all of their products and services inside as well as outside of the cloud as APIs, so we can programmatically work with them from anywhere. The Translate API is a really cool one. It allows us to obviously provide translation services. We can translate to and from strings. We can programmatically detect a string or a document's language, and it's really easy to work with. Another really neat API is the Prediction API. This is where we can predict trends based on historical data. And the popular use cases are usually spam detection and product recommendations, but there's other ones like customer sentiment analysis. Say we've got a bunch of products on a page where people leave comments. We can scan all those comments to see what their tone is, negative or positive. We can do churn analysis. We can do suspicious activity identification. There's a lot of neat things you can do here with the Prediction API. And of course, it integrates well with other GCP services where our data might live, BigQuery and Cloud Storage, to name a few. We also have a nice range of networking services. Carrier Interconnect, for instance, allows us to use enterprise-grade connections to connect our infrastructure to Google through a service provider. So literally you, service provider, Google. There's also direct peering, which allows you to get right on to Google's infrastructure by connecting your infrastructure to their edge network. So literally you, Google. And then there's also Cloud VPN. This is where we can use the advanced networking features of Compute Engine to set up a secure tunnel between our existing on-prem networks and our Compute Engine networks running up in Google's cloud. We also have Google Cloud DNS, which is great because now we're giving developers the power to programmatically handle DNS, which is a big deal because DNS is usually a roadblock. You have to jump through hoops or go through somebody else to get it all set up and configured. Now we're giving that power to the developer through Google Cloud DNS. We also have two flavors of load balancing. HTTP load balancing, otherwise known as global load balancing. We can actually do two kinds of load balancing in here. We have cross-region load balancing, so we can literally balance traffic across Compute Engine regions, which is great because, again, if we have our application spread out across multiple regions and a region goes down, traffic will go to the next closest healthy region and get served from there. The other side of HTTP load balancing is content-based load balancing, and this is also very cool because we can optimize servers to handle specific types of traffic. So maybe, video content. And then requests for that kind of content will get routed to those servers that are optimized to handle it. Neat stuff. And then we also have network load balancing, which is within a region, right? So we can balance TCP and UDP traffic within a region, and only healthy instances, again, will handle that traffic. And in both of these cases, we have an extremely scalable load balancer that doesn't require any pre-warming. That's a big deal because it's ready to go and it can scale up to millions of requests per second without a problem. Finally, we have plenty of management services to make our lives easier when doing things like configuring, managing, and monitoring our solutions. Google Cloud Monitoring gives us insight into how our cloud infrastructure and our cloud applications are performing. We've got lots of dashboards up there. We can create our own alerts to be proactive. So when certain metrics or thresholds are hit, we can get notified immediately. Next up, we have Google Cloud Deployment Manager, one of my favorite tools here in the Google Cloud Platform because I'm all about declarative management and declarative configuration, and that's what Deployment Manager does for us. We shouldn't have to manually stand up environments anymore. That's a lot of manual labor and a lot of time. We should be able to just describe the state of our environment in a template, right? And then pass that template off to something, and that something will spin up that environment for us. That's what Deployment Manager is. It's that something. Another great time-saving feature here is Google Cloud Launcher. We can launch entire software stacks on Compute Engine with just a couple of clicks. It's really easy to do, really fast, and it gives you a great starting point for your own infrastructure. In fact, in the nugget immediately following this one, I'll give you a demo of Google Cloud Launcher and show you how we can spin up our own LAMP stack. Finally, we have Google Cloud Logging. So everything that happens in our GCE instances and our GAE applications is logged. We have a nice log viewer that we can use to see all of this information, and we can even export this data to Cloud Storage or BigQuery for analysis. In the CPT Nugget, we took a big tour of Google Cloud Platform services. We saw that Google's Cloud has a lot to offer. We can mix and match a lot of these services together to come up with a truly custom cloud-based solution. I hope this has been informative for you, and I'd like to thank you for viewing.